Welcome to the QuantUniversity Take 5 series. My name is Sri Krishnamurthy, and in today's segment, I'm going to be talking about the 8 steps you would need in order to build out a machine learning application. So when people talk about machine learning applications, they'll always be thinking about, well, what data I'm going to be using. The second step would be what models am I going to be using. And the third thing would be how am I going to be using these models. Now, that's typically what you would do if you're building out a Jupyter notebook, ingest your data, build out your machine learning models, and then build out a model which could be used for prediction. But in an enterprise, you had to think in a bigger scale. You had to think about, well, what kind of a pipeline do I build so that you can start working from the ingestion process and then think about the whole deployment process so that you can use it in a production application. So there are 8 different steps you had to think about. So let's talk about these 8 different steps. So typically, the data engineering group would be basically made responsible for the first 4 steps. And the first 4 steps are the most critical piece of the puzzle, because if you don't have quality data, you won't have a quality machine learning algorithm. So the first 4 things, what people would typically do in the data engineering realm would be to first think about what kind of data am I going to be ingesting? Where am I going to be getting my data? Is it going to be scraped from a particular website? Is it going to be something which we'll be ingesting from a particular data source we are buying? Or is that data we already have available? So once you decide what data you're going to be using for building out your models, then you have to start understanding your data sets. So typically dashboarding tools or visualization tools would be used to understand the variability you have in your data, what kind of parameters do you have, what kind of cleansing would potentially be needed, what elements could potentially be left out because those are not relevant for your models. All those would typically be done in the context of exploration. The third step in the data engineering pipeline would be to cleanse and pre-process the data. As you all know, data never comes clean. So you may have to think about various ways in which you can enrich your data, maybe through cleansing, maybe through augmenting, maybe through joins. You may have to think about various pre-processing steps so that the data is clean enough so that you can put it into a machine learning model. The fourth step of the puzzle is the most important piece, and that's feature engineering. Now you have to think about which particular features are going to be relevant for your models, and then think about how you can enrich your features or maybe do dimension reduction or bring in multiple different ways in which you can enrich your features so that you can have a robust set of features which could be used for machine learning models. So typically, these 4 steps would be done by data engineering groups so that you have your data clean so that you can start thinking about building out your respective machine learning models. Then comes the role of a data scientist. So typically, data scientists would take data which has already been cleansed, and then they would be thinking about, well, how can I structure my problem? Is this a supervised learning problem or an unsupervised learning problem? What kind of algorithms can I potentially be using? Should I be using regression? Should I be using neural networks, KNN, decision trees, etc., etc.? They have various tools in which they could be thinking about structuring these problems, either in a supervised, unsupervised, reinforcement learning problem, or a semi-supervised learning problem setting. And that's where they think about structuring these algorithms so that you can leverage the data sets you have already collected and build out the respective models. And then comes fine-tuning. You have to think about what parameters I'm going to be using to figure out whether my model is good enough for my production setting. Then think about various parameters and hyperparameter choices and figure out how best can I build out my model so that I can reach the specific objectives I have in mind. And I've presented some of the various metrics people typically use, maybe a root mean squared error, a mean absolute percentage error. Depending on the class of problems, if it's a classification problem, you may be thinking about a confusion matrix or an ROC curve. So depending on the class of problems, you may have to think about generating various matrices. Now, once you have fine-tuned your model and you have your model ready to go, you may have to think about, well, how do I choose my models? Do I think about interpretability? Do I think about who's going to be using this model at the end? What level of explainability they may need to have once the results are out. So they may have to factor in all these business constraints and all the usability constraints to select the respective model they could be using in a production setting. And finally comes inference. So once you have your model ready, it's ready to use. So you had to think about, well, should I be giving this model to someone who's going to be passing in respective data sets in maybe a Python program or an R program, and then generating these outcomes? Or will this be deployed at a REST API so that another service could potentially invoke these algorithms and then get back the results? Or it could be used in the context of a full-fledged application, which could take inputs from multiple sources and then generate the respective outputs. Depending on the use case you have at hand, you had to think about a whole inference and a deployment pipeline so that you can factor in all these requirements, specifically the end user requirements. Most of the time, data scientists, once they have a clean model which has been fine-tuned, hand it off to the software engineering or the technology teams who would be tasked to take these models and deploy these models into production. And at the end, the decision makers or the analysts who are going to be using these models will be testing these models and then figuring out whether it makes sense for them to use in a production setting, and then they'll be using this model. What's happening is, as the machine learning profession has matured over the last 10 to 20 years, there's been these abundant thought process in terms of not just looking at the model itself, the entire process you have to think about when you're building out these models. And that's where the machine learning workflow comes into play. Hopefully this segment was helpful. We'll see you again in the next segment of QuantUniversity Take 5. Thank you very much.